In this week's video, we are going to build a sweet-looking 486 class retro Dream Machine and restore rebadged Sony Trinitron GDM20E01. Okay, I went through my pile of messed up boards and I found one that is almost undamaged. So this is probably what we'll use. It's untested though, so we need to make sure and see if it actually works. There's a tiny bit of corrosion underneath here, but that shouldn't take more than a couple of minutes to fix. This board is marked GMB486SG version 2.2. I'll check on the RetroWeb and see if it's any good. Before we start building this machine, let's first do complete disassembly of this massive Sony display. That way I can clean it and leave it to dry while we build the PC. This is actually my favorite CRT display. The image is perfect for retro gaming. There are some newer and technically better Sony Trinitrons, but nostalgia couldn't care less. We have actually restored one of these on the channel previously, but that Sony display had an Apple badge. But they are the same, except for the connector at the back. Okay, I think those 4 screws should be enough to remove the lid at the back. And if you were in doubt, here's the Trinitron sticker and a model number. This guy here is manufactured in 1995 in Japan. So this is the good stuff, despite that deceitful HP badge on the front. The only thing bad that can be said about these is how incredibly big and heavy they are. This display is absolutely massive and really hard to move around on the bench. So first we need to remove a whole bunch of these screws to remove the shield inside. Okay, about 10 screws removed. And now the shield comes off. Okay, well, we do have some soot in here, but nothing excessive. So this display should have many more hours of retro gaming left in it. And my usual disclaimer, of course. Please don't mess around inside CRT displays. They may be charged with high voltages, even with the cord unplugged. It's been a while since I worked on one of these, but I actually found the manual online. And apparently the first thing to go is the power supply. Cables and connectors are almost always keyed or marked in some way. But just to make sure, I always take pictures. That way I don't need to do any guesswork when it's time to reassemble the display. Okay, let's have a look inside here. Just like the Apple branded Sony, there are no nasty Refas or Vima branded caps. And the electrolytics look good too. And the next thing to go is the neck board. So we need to loosen up a screw underneath here. Disconnect all the cables and then remove the neck board. And next we should be able to remove the panel with all the connectors at the back. And with the panel off, I think we can remove the PCB tray next. Okay, let's see if it's free to come off. And it is. With the tray partially removed, we can now reach the remaining connectors. Okay, same thing here. Everything looks good. None of the caps are bulging and I don't see anything out of order. But here's the reason why I like to wash my displays. It has collected quite a lot of dust over the years and it has to go for 2 reasons. First of all, it's flammable, and secondly, it will collect moisture over time and can cause some problems. The only thing that has yellowed on this display is the stand, so I'm going to leave it in peroxide while we build that 486 machine. And here comes the stand, I think. Yep. Now we have access to remove the front panel. This is a pretty late CRT display, so it has tons of adjustments on the front panel. So it's much easier to adjust the image. And here comes the front panel. To remove the tube, I like to use the large book, and then a mouse mat on top, and then I place the tube on top. That way I get some space underneath the bezel, so I can drop the bezel down when I have removed all the screws. Being a Sony, it's quite easy and straightforward to work on. It doesn't use an excessive amount of different types of screws or any hard to reach connectors. Now we can remove the metal frame inside. Since the tube is raised off the bench, I can get my hands around it and pull it out of the bezel. Now for the hardcore fanboys, here's the part numbers. Sony Trinitron made in Japan. Okay, that was actually the whole disassembly. So next I'm going to dry clean the tube and wash the rest in warm soapy water. I'll do the cleaning off camera, so we can move on and build that machine. Okay, I think we have a theme going on here. That display was manufactured in 1995, and at least this chip here is manufactured in week 1, 1995 too. So let's go for 1995 486 class Dream Machine. And actually recognize this board. This is the board we used when we repaired the Left 4 Dead machine, because it has a bunch of green dots all over the board. Those are markings from when we traced how 2 of the chips were connected, so we could fix a trace on the other board. And speaking of which, you know how bad the Varda damage can be on these boards. But this board here is super lucky. This is all the damage there is. The solder mask is slightly damaged on this side. So all we need to do is to clean it off and tin those 2 traces. And this side is even better. There's just a tiny black goo on this through hole here. And that's it. So this is one lucky board. And I found the board on the retro web, of course. I would have been surprised if I hadn't. And apparently this board is a DTK PKM 0038S. Also known as Gemlite GMB 486SG version 2.x. It's an SIS 85C471 board, and obviously 486 VLB board. It will do up to 50 MHz, so that is excellent. It can take 512K of cache, which is more than I need too, and up to 128 megs of RAM, which would be a silly amount of RAM to add to this board. We'll probably go with 16. And if I'm not mistaken, it has a 4x jumper. So this is a great candidate for an AM5X86 build. And it will do a whole bunch of different voltages too. It can do 3 volts, 3.45, 5 volts obviously, and a couple of more voltages. And at the moment it has a Cyrix 5X86 100 GP installed. So we are definitely going to replace it for something faster. Okay, let's start by cleaning up this mess here. And it actually looks like someone used a green Sharpie to cover up that corrosion. I'm not sure what's going on here, but it definitely looks suspicious. So I'm going to use my green rubber tip on the Dremel. Okay, let's see if this will come off. Whatever it is. I guess it could be solder mask. This is boring to watch, so I'll skip ahead here. Okay, that only took a couple of minutes. So let's add some flux. And a large flat tip. And a splash of fresh solder. And we can now tin these 2 traces. I'm not going to bother with solder mask, because the solder will protect those traces well enough. Okay, I think that's good enough. So we can scoop up that flux. I'll use some IPA to remove the stickiness. Okay, so this trace here is a tiny bit thinner than it was originally, but not enough to worry me. So I'd say this is fixed. Those 2 traces are going to outlast many of the chips on this board. Okay, next we need to add a battery instead of that nasty Varda that used to sit here. I usually just bodge on a regular coin cell holder and a diode. That has worked well enough for me. But it's not a very elegant solution. So that brings us to the sponsor of this video, PCB, because I ordered some PCBs to fix this. These are tiny little buggers. I'm gonna have to move in real close to the camera. So there are many different variations of this project online, and these were designed by Scrap Computing. One thing that's different from other projects I have seen is that these boards can take 3 types of diodes, and they are about the size of the original battery. So I think this should make for a really neat installation. I don't have any surface mount diodes, so I'm gonna go with a through-hole diode. But I'm going to solder it on the same side as I install the diode. This way the board remains flush on this side. I ended up doing the same thing with the pin headers. So the PCB is still flush on top. So with the coin cell holder installed, it all looks pretty neat. And here's the finished PCB. That's a hell of a lot nicer than my usual bodge. So what we need to do now is to install it on the board. Okay, so these coin cell holders are larger than the original Varda battery. So on some boards you may have to go with a vertical holder. But this board here, it looks like it's a match made in heaven. Look at how tight it sits to this chip here. And the SIM slot here. And of course I'm going to install a Varda battery. I mean, look at these guys. They are so happy playing with a Varda battery. Of course we're going to use one. Well, another thing that came out in 1995 is the AM5X86. So that should be an obvious choice. So these are designed to run at 133 MHz, but apparently we have successfully run this chip at 160. And on top of that chip we're going to install a Cooler Master GI5 4015 apparently. Certainly not the best solution for a fast chip like this, but I'm working on finding something better, so I'm gonna get back to this in a future video. Okay, I found a GD5429 VLB card and installed it. I also installed some RAM and connected power. Now let's see if that board will post. Here goes. Well, a tiny little fan spun up. And it's posting, awesome. And apparently it's running at 120 MHz. And we have 16 megs of RAM. Okay, so I guess we should do some benchmarks. And that took an obscene amount of time. This stupid motherboard just refused to boot. I went through a whole box of controllers. But the damn thing just hanged. It started to boot DOS, but then it crashed. I tried with 2 different hard drives, but I got exactly the same result. So I was sure it wasn't the hard drive. Only problem is, it was the hard drive. 2 of them. At the same time, showing the same fault. That was just a bizarre troubleshooting. Okay, so a few hours wasted. But now the machine is up and running. Oh, come on. Now the keyboard died. I'm having a bad day here. I guess I'll swap that keyboard. And I'll fix it some other day. Okay, let's try that again. This one is actually faulty too. But it's just an arrow key. We don't need it right now. And I guess I have 2 Model M's to fix. Okay, let's try that again. Okay, let's check in SpeedSys first. Okay, and the system recognizes an AM5X86 at 75 MHz. That's odd. This doesn't make any sense at all. And the score we're getting is spot on. An AM5X86 running at 133 MHz. And we've got 16K of level 1 cache. But it made a really funny drop at 16. Never seen a 5X86 behave quite like this. But I think it's working. Let's have a look in check CPU. Okay, and it recognizes a 5X86 running at 133.7 MHz with a clock multiplier of 4 and a bus clock speed at 33. I wasn't sure if this board had a 4x multiplier because the manual is a bit unclear about what jumper does what. It just gives you a list of how to set all the jumpers for each CPU without telling you what the different jumpers do. But this is actually excellent, so that means we can run the CPU a bit faster than this. But the BIOS doesn't seem to recognize it, and it's reporting a 486 DX2 Plus. Whatever that is. But that's not uncommon, that the BIOS gets confused by the 5X86. I'm not going to overclock this board until I have found a better cooling solution than this. That dinky little fan is not going to cope at higher speeds. So let's run Doom next and see if the board is stable. And Doom should be playable at this speed. No, it's not. Oh crap, I forgot the cache. We need to add some cache to the motherboard. Okay. This benchmark is pointless without cache. Or it could actually be an interesting comparison to see how much speed we get from the cache. So I'll let it run. Yeah, definitely too slow. I guess it's sort of playable if you like slideshows, but definitely not enjoyable. Hey, where's the score? It didn't give me a score. Just went to press any key to continue. What's up with this? What? Never had this before. I guess it was so slow, it just ignored me. Okay, install a fresh copy of DOS Bench. Let's run Dooms again and see if we get a score. I'll skip ahead to the end here. Okay, now we're getting a score. 14.19. That is pretty lousy. So let's add some cache next. See if that improves. Okay, cache installed. And I checked all the jumpers and they are set correctly. Let's check in SpeedSys again. Okay, now it thinks it's running at 79 MHz. Performance is about the same. Now let's see if it will recognize our cache. Okay, dropped at 16 and it still bounces around before it drops. And then it drops at 256, but that is a tiny drop. So something is off here. Either we have some weird compatibility issue or something is messed up with this board. Let's run Doom next and see how it behaves. And it's still slow. Something is messed up here. Okay, in that case I'm going to move the hard drive from the VLB bus to regular ISA and see if that is our issue here. Okay, the hard drive is now connected to the ISA bus with a different controller. Let's see if that was the issue. No, still the same behavior. Oh, the turbo switch. I forgot to check the turbo switch. Oh crap. Let me check. Okay, and it's actually completely missing here, so I couldn't really say if it's in turbo mode or not. Let me check the manual. According to the manual, it should be in the left position for turbo mode and in the right position for deturbo mode. But on this board it's completely missing. So I'll install it in the left position and we'll try those benchmarks again. Would you look at this? We're not running at 79 MHz anymore. Funny that the score was the same. I don't think these benchmarks are all that good, but it's still a useful software. And that weird bouncing disappeared. And if I'm not mistaken, it will drop nicely at 256, just like it should. Okay, let's run some Dooms. Here goes. Yeah, that looks so much better. Now this is definitely playable. And at this speed, also enjoyable. Oh, what a silly mistake. Well, I'm not sure if it's a mistake, but I should have suspected that turbo jumper much earlier on. Let's see what score we get. I'm gonna guess 35. 34.87. That was not a bad guess. So this is now a Doom machine. Awesome. But there's one more thing I want to try. I have the hard drive connected to the ISA bus now. So next I'm going to connect it to the VLB bus and see if it makes a difference in benchmarks. Because I've never tried that before. While troubleshooting, I swapped that VLB controller for an ISA controller. And I may have excluded that from the video, since it did make a difference. But now that the system is up and running, let's see if there is a difference between an ISA controller and a VLB controller. The VLB controller also has pin headers for ISA, but now it's connected directly to the VLB bus. I have placed the graphics card in the first slot and the controller in the last slot. And I don't know if it makes a difference. I think they're all just connected directly to the bus. Oh wow, that made a huge difference. 38.38. So that definitely made a difference. Holy cow. I would never have guessed. Well, it kind of makes sense. But I thought the hard drive is so slow it probably won't take advantage of being connected directly to the bus. But there you have it. 38.38, almost 40 FPS. Trying stuff out and learning something new every day. Well, I'm gonna say this board is ready for a 1995 486 class Dream Machine. So let's start building stuff. And here's the case we're going to use. I don't know who made this case. Perhaps we'll find something inside that will tell us. It looks to be a pretty late 486 case, at least by the looks of it. But I'm not entirely sure. I'll show you why in a minute. So this case has a key lock, a reset switch, turbo switch, and a 7-segment LED display. But unfortunately we won't be able to use it. Let me show you why. This case has a motherboard tray for a quick and easy installation. With the screws removed, we can just fold that tray down and install the motherboard. Now, how is that for a weird 7-segment display? This thing has an IC with the silk screen removed. And then it has a coin cell holder. And even worse, it came connected only to the reset switch and nothing else. So instead of having the usual pin headers, this thing seems to be running off a battery with this IC, and the displayed speed is probably set with a reset switch. And without a manual, there is no way we can set this display. I'm afraid we're gonna have to leave it disconnected. Oh, so this display only has 2 digits, and this board is now running at 133 MHz, so it's not very useful. Oh, there's actually a date stamped here on the front panel. Let me check those numbers. Okay, 1992. Well, I guess that makes sense, with just 2 digits on the display. But the design on the front panel looks kind of newer than 1992, so I was sure it was several years newer. My other 486 cases look much older than this. This case definitely has a 90s look to it, those wavy lines. Well, I guess I was wrong. Okay, I went through my stash and I found a nice double-speed CD-ROM drive manufactured in, well, you guessed it, 1995. For sound, I'm gonna go with this CT2950. This card too is manufactured in 1995, so we are almost perfect, period correct 1995. Everything except for the case. Oh, actually we're not, because there isn't room enough for that card in this machine. The VLB controller takes up 2 slots here because of the cables. Now these slots here, they are too short for that long card. So I need to source a shorter card for this build. For now we're going to install an ESS 1868. These are good cards, but I guess not as interesting as the original Sound Blasters. Okay, time for a test. Here goes. The hard drive spun up. We got a beep. Board is still posting. One of the LEDs lit up. And it boosts to DOS. So apparently the power supply is good too. And now our 1995 display is back from the wash and ready to be reassembled. And all the dust and soot is gone, except from a few minor scuffs on the case. All the parts look pretty much brand new. I often get the question how I wash my stuff, so if you're interested, check out my Mac SE30 video. Well, I'm not gonna lie, that took some effort to reassemble, but I'm not gonna complain. These are not made anymore, so having one of these in such a nice condition is of course totally worth a couple of hours of work. I'm gonna leave the back off while we test it. Okay, power connected, but not turned on. Here goes. I heard a relay and high voltage. Everything seems normal. Let's turn that machine on. The display is doing something. Got some more high voltage. The LED turned green. Okay, we're getting something on the screen here. Okay, at least it's working. Let me try different camera settings. See if I can match that refresh rate. So the image flashing here is the camera's doing. And unfortunately I couldn't adjust my camera for the refresh rate of this display. So you're gonna have to take my word for it. There's none of that flickering in real life here. That image is excellent. It's absolutely perfect for retro gaming. These games were made for CRT displays, so at least to me they look way better than on a more modern display. So that's a win for sure. There's actually one more thing I want to try today. I read somewhere a very long time ago that the graphics card should be installed in the first VLB slot for best performance. So that is why I swapped that sound card, instead of just swapping slots with these 2 cards, and make room for that larger sound card. So let's find out if that is actually true, and install the graphics card in the second slot. Okay, said and done. So the controller is in the first slot now, and the graphics card in the second slot. Plenty of room for a large sound card here. Okay, well it's still posting, so it does work at least. Now let's see if it affects the score. There's a lot of incorrect information online, so I find it worth testing and confirming stuff like this. Well, the game is still perfectly playable and smooth, but obviously couldn't tell if there is a tiny difference. Not really, no. That is marginal. 38.36. I think we had 38.38 in that previous test. Well, in that case, I can install whatever sound card I want on this machine. That's excellent. Oh, maybe I spoke too soon, because now the machine doesn't post. I'll restart the machine a couple of times and check to see if it's stable. No, it didn't post on the third attempt either. So, I guess that information was correct after all. Having the controller in the first slot and the graphics card in the second slot seems to render the motherboard unstable. At least my board. I'll swap them back again. And with the cards swapped, the system now posts and boots. Okay, so then we know. I guess I'll start looking for a short Sound Blaster from 1995. Well, you guys know me. I obviously want to overclock the crap out of this machine too. So I'm gonna start looking for a really good cooling solution that doesn't require me to glue a cooler on top of the CPU. And we'll get back to this machine in the future. But that's all I had for you guys today, and I'll see you again next week.